we're graphing relations, guys. The first example we're going to deal with is relating graphs to situations. So, backwards here. So, the cool thing about relations is that they are a representation of things that are connected. If something's related, they're connected somehow. And when we can't actually see or visualize something, the cool thing about mathematics is that it allows us to create with a graph something visual that doesn't really seem so visual. So we're relating graphs to situations here. And let me just draw up a graph here. This problem says this, guys. It says the air temperature was constant for several days. So this air temperature was constant for several days. Actually, several hours at the beginning. Can you not see that? No. You guys can. I think y'all are just high maintenance. So I'll fix that. You guys should be able to see that. Beginning. Stop talking. Hey guys, guess what? Stop talking. Is at the beginning of the day. Can you still figure it out with your brains because y'all are so smart? No. That's too bad, smart Alex. Stop. Okay, guys. For several days, several hours, I keep saying days. Stayed the same temp for most of the day. Ha. Okay. I'm just gonna read this to you guys because that's kind of still. All right, so basically the air temperature was constant for several hours at the beginning of the day and then rose steadily. So it rose steadily for several hours, and it stayed the same temperature for most of the day before dropping sharply at sundown. Choose the graph that best represents the situation. So let Mr. Gillespie draw you some graphs here. You are probably saying, hey, dude, I don't even see a graph. I don't know. So we're going to draw our first graph here, and the first graph is going to do this. Hey, Alex. So here's graph 1. Now let's just go ahead and...
Are you recording this?
I am. What's that? So I can post this up on your website later.
I know, but I don't think it's recording audio.
It's recording audio and video for you guys, so when you go to study it later tonight, if you forget something, you can always come back to the video. All right, so anyway, back to the graphs. We have 3 different graphs. And first graph here, graph A, obviously. If you can't see that, I'm telling you, this is graph A. It'll show up on your computer just fine. You have graph B. Graph B. You also have graph, I'm going to scroll this to the side just so you can see. You got graph C. Well, anyway, guys, I have 2 axes. I have an X and Y axis here. And my X axis, we're going to deal with time here. So as time marches on is how we're going to look at this. Another way to look at this is a stopwatch. But here, my temperature, the dependent variable. So I'm just going to call it temp for now. So temperature off to the side. And again, this would be temperature and time. Temperature and time. All right, so we got 3 different graphs here, but the first graph that we have as a visual here does this, guys. Let's just increase this size a tad bit, just so you know. It's going to start here, kind of do this sort of deal. It will curve up, curve down, curve down, and then just straighten out. And then the second graph, what it will do is just kind of start here. We'll have it curve up, kind of plateau and then just drop straight down. Then the third graph, what it'll end up doing is it's going to start all the way down here, go up, plateau, bump up, and go down. Well, we don't know that for a fact yet. So now let's go back to the problem and actually see what it's telling us. And let me see if I can do one thing before we go back. Settle down because we are going back to the problem to actually put in something that we did not before. And here it is right here. You guys are going to say, Mr. Gillespie, you didn't put anything on the screen. You must be silly. I put a box. But wait a second. That's right. It's totally exciting here. And what I'm going to do is let's increase the size of these nuts. And let's change it to green. We'll color it. There we go. Here we go. And guys, stay focused. So now let's actually, we'll just scroll down the screen just a tad.
That's interesting. That enhanced our learning.
Hey, Alex, you want to stay in here and work with us, bud? I know, it just kind of shot out. So I'm just fixing it for us. Okay, that's tough to see, so I'm going to change it to, oh, let's see what happens. There we go. Go to yellow. Okay, so we should be able to see what this says now. Well, it's chopping off the very end, but that's okay. I will explain what that says. This says the air temperature was constant. So before we decide what the graph is, we have two steps we have to do. The first thing was we have to read the graph from left to right. And while doing that simultaneously, think about the question and ask yourself, let's list key words in the statement down here and see if it actually reflects what the graph says. So the first thing this says is the air temperature was constant for several hours. That tells me automatically I can cross out one of three graphs. And which one do you think that it's going to be, Jacob Malandano? Why C, buddy? Well, what's my where's my keywords in the statement that tell me to cross out C? Yeah, constant for several hours. So this part right here is telling me, hey, this graph does not start at 0. So I'm just going to cross this out. And now I'm going to go to my second value, or my second part of the equation. I'm just going to move to these other two graphs and start reading some more and say the beginning of the day, and then rose steadily for several hours. So that tells me, Hannah Shirley, what do you think that's telling you, kiddo? That's going to rise. So what graph does that reflect right here? That if it's rising steadily, so it was A and B can work because it was constant. Constant says, hey, this could be constant equals, for graph terms, constant could equal horizontal, guys. And cool. So rose steadily tells me what, Hannah? Yeah, this tells me it's going to have an upward slant. It's going to have an upward slant. Does it say it shot straight up? No. Does it say it accelerated from 0 to 60 in 0 seconds? No. I mean, it's saying, hey, this is rising steadily, so it's going to have an upward slant. The real trick here, guys, if I'm misspelling this or anything, don't worry about that. Just understand what I'm writing and fix my writing on your own paper. Hey, but here's the problem.
Yeah, what is this?
Huh?
Slation.
What do you think it's to mean? What did I say? Upward what? Slant? Perfect. Thank you, guys. If you're focused and listening, then you won't have to worry. Guys, here's the thing. What's this saying for time? It's saying, hey, look at this as if it's a stopwatch. You're watching time go on. As it continues, let's look at what the problem is saying and see if we can reflect the two. So the same okay, so this rose steadily. So, hey, Hannah, this works for what graphs? I'm talking to Ben here. Ben, what two graphs can I be looking at now?
Now,
Or three graphs or one graph?
what?
What graphs am I looking at with it rose steadily?
The first one is manual.
Well, the first one works. However, B still works. We know that it's rising steadily. This is a more accelerated rate, but we don't know how fast this is. This could be, and we don't know how long this is. This could actually be an hour. It could be 30 seconds. So we just know it's rising steadily, okay? So then it says this. It says, Mr. Lee Balboa, what I want you to tell me is what's the next part, what's my next keyword in here? Stayed the same temperature. So what I'm going to do here, what stayed the same temperature look like on a graph? Does that mean that it's rising or what, Lee? And a good term that we've already written down to the right would be what? Yeah, or constant, and constant means that the graph is horizontal, right? So it means that stayed the same means horizontal. There you are, Mr. Gavin, spelled it correctly for you. So then it says it stayed constant for most of the day. So now which one does it automatically make it?
B.
Well, now we've got a bit of a problem when some students are saying that it's graph A, and then some are saying it's B. So let's look at why it might be graph A, Nilan. Why would it be graph A?
Because it goes upward and then goes down, stays constant.
Well, now stays constant doesn't mean it goes down. This is, look what it's saying, but it says, hey, the temp was constant, so it was horizontal, and then it shot up, it rose steadily, so it went upward slant, and then it stayed the same for most of the day. So is this one staying constant for most of the day? Whereas this one could be. Which one's more accurate, this one or this one? B so far, so let's figure out if it finishes correctly. For most of the day before dropping sharply, and it says, hey guys, this dropped sharply, it's going to be B over A.
Yeah.
So it drops sharply here, which means, drop sharply means it's a downward slant, so I'm going to circle B as my answer. What's up, Jacob Hill?
Doesn't the cutoff things mean it drops sharply at sundown to choose the graph?
Say this last part again.
Isn't the cutoff part sundown when it's to choose the graph?
For time?
No, the cutoff part.
Other words.
That'd be,
Yeah, oh yes, thank you. This is sundown, choose the graph. Thank you. That's a great question. All right, let's move on to a second one. So there we were talking about relating graphs to situations. We read a situation and then said, hey, what graph could it be? Whereas, hey, you know what? Sometimes you can sketch graphs for situations. You can actually read a situation and then write down or draw a graph based on it. So what I'm going to do is scroll down some and we'll move forward from here. Let me pull up the question for you real quick, just so we're on the same page. Do-do-do. Do-do-do, Trevor. Check this out, dude. That's right, man.
Whoa. Yeah, Simon.
What's that, bud?
How? What? Who cares?
Okay, here we go, guys. Moving forward from here. How much time do we have on the clock, boys?
About 20 minutes.
20 minutes? I'll finish this one pretty quick, hopefully. So, here we go. Here's what this says. Hey, guys, Simon is selling candles to raise money for his new show, American Idol School Dance. For each candle he sells, the school will get $2.50. He has 10 candles that he can sell, so let's create a graph on this because we want to know how much money he can make. But here's the rub. The truth is, we don't know how many candles Simon is actually selling because Simon can sell no candles or he could sell an entire collection of 10 candles. So what we're going to do from here is say, hey, let's create our graph. Guys, where's your focus? On the awesome graph. All right, so here's the deal. Along my x-axis here, Peyton, I'm going to have you move in a second if you don't chill out, buddy. So here along the graph, I know the most amount of, well, first of all, what is my x-axis? What could I label this? Because I don't have time. I'm not dealing with time, so what am I dealing with? Amount of what? The amount of candles sold? The amount of candles sold. So let's say, okay, well, these are going to be my candles. Why is it candles over the money? What's up, Ian?
Because the number of candles is the
Yes, say it.
value that you change to
It's your control, isn't it? You're controlling the amount of candles. Or another way to say it, it's independent. It's independent, dude. And if it's independent, guess what that makes money? Money's dependent. The amount of money that you get is dependent on how many candles you sell. So let's get back on track here, Cody. And what we're going to say is, hey, he could sell 10 candles, but somewhere down here, hey, what should I make my halfway point here? My midpoint? 5, absolutely. So that's going to totally make this first point down here 0. And that means that, well, halfway between here is between, well, you know, the truth is I can't really sell 2.5 candles. So there, technically don't do that. Technically, we're not going to say it. We're not going to cut a candle in half because Simon doesn't want to make half on his money. We want to say, hey, he can get $2.50. The problem doesn't tell me he can get half of that. So what I'm going to do here is instead of writing 2.5, I'm going to write 2. And I could write 3. And I think you guys understand the rest. 4 and 1. And now let's go to 6, 7. So what I'm really writing are complete units, not portions of it, because you can't cut candles in half. Technically, guys, I understand you could, but Michael Dell, is he going to sell half a computer? No. So Simon's not, he wants to be like a Michael Dell. He's not going to sell half a candle. Okay, now here's my, now if I multiply 2.5 times 10, I know that the most he can make without tax or profit is $25. And the least that he can make is 0. So I'm just going to actually just raise these by units of 5 and make it simple. So now I got 5, 10, 15, 20. All right. So now what I want to know is, well, how much money can he make per, what if he sells 0? This might actually be a case. He might sell 0 candles. So he gets $0. Which means that if he sells 1 candle, he's going to get $2.50. It's somewhere in between 0 and 5, so I'll just put it here. And then also for 2 candles, it's just doubling $2.50 to $5. So you know that every time, let's go to 3, he goes from $5 to $7.50. But that makes sense that if he sold 4 candles, it doubled from 2, so 5 doubles, goes to $10. And let's just double from here, guys. 5 would be $12.50, but 6 would be $15. And then 7 would be $17.50, which makes 8 $20, which would actually, if I increase by 5 more dollars for 10 candles, well, he'd make $25. And now, if you notice here, I sort of have discretely put points down, or I have discrete points on my graph because they're not continuous. He can't sell a part of or a piece of a candle. He's selling a whole candle. So all I can say is, hey, if he sells 0, then he has $0. If he sells 8, he has $20. So what we're dealing here with is a discrete graph rather than a continuous graph. I don't have a line connecting point to point to point to point to point. All right. So we'd call this, guys, just for reference, discrete graph. Pretty neat.
You know how big the world's biggest candle is?
Hey, Alex. You know I'm not talking, buddy. You know I'm not talking, Alex. Because I want you to be quiet. All right, guys. Hey, let's move on from this to another one. So we've looked at how to, with graphing relations, how to graph graphs because it helps us to visualize what we don't think is there or have trouble seeing. to sketching graphs from situations. So we've read from a situation and picked out graphs. We've drawn sketches of graphs tailored based off what we've read. And now we're going to actually look at, or you're actually going to look at, writing situations from graphs. So in this third problem here, what I'm going to do is, let's just get you some fresh new material. And what I'm going to do here is I'm going to create you guys a graph, and you guys are going to say, awesome. So now, all right, so here's our graph, and then the situation that I'm going to draw is something like this. Well, cool stuff. And now what I'm going to say from here is, well, let's call this bottom x-axis, I'm going to call it time. And, well, from here I get to make up any story that I want. And, Alex, what's up, dude?
I've got a good scenario.
Oh, you do? Let's use it. Possibly. I've got one too. So,
Whale dives down
uh-huh.
to some depth, like we'll decide later.
Yeah.
He stays at that depth.
Nice. Nice. I like this. Whale diving. I got a better one. I got a better one. I got a better one. A dolphin dives down. Dolphin dives down to a certain level underwater. You like that rather than a whale? Just kidding. All right, hey guys, we're gonna use this one. We're gonna use water. So the water level here, guys, in a sink. The water level in a sink. What's up? No. We're dealing with the water level of a sink. Put your hand on your head if you can hear me. Put your hand on your head if you can hear me. Thank you. Guys, we are dealing with water in a sink. So here, we know that a whale cannot fit in a sink. So we know here that the water level is at 0, and time would be at 0 on our stopwatch, because this is saying as the arrow moves on, time is marching on. As this water level moves on, it rises the higher up this graph goes. So the water level already is filled into the sink at some level. There's a certain amount of water in the sink. However, as time marches on, I don't know, someone pulled the drain from the sink, so water's draining out of the sink as time marches on. However, it doesn't really drop to 0. Somewhere around this point, someone must have put the plug back into the sink. And it stays constant for a while. And then somebody at this point says, you know what we really need, we need to get more water in our sink again. I don't know why. Maybe they want to wash their face or something. So what they do is they have the plug already in, but they turn the faucet back on, and they refill the sink up to the same level that it was at before. And I could write all this down within a sentence, and that's basically what we got to do right here, is that I'm going to just state it all right here. I liked the whale one too. It was creative, but it was getting silly in here, so I changed the situation. Okay. So here's our story. Water level in a sink. Water is constant in a sink, or stays constant in a sink. Huh? Let's do this. Let's just rewrite it again and say a sink is filled with water. Now that W, guys, that's a great question. I know you're already raising this is a good note-taking tip. Instead of writing full words, you can use shortened letters or symbols to represent a word. So W with this slash after it typically means with. And we write the word with thousands of times within a year. So rather than within notes, rather than writing with the whole word out thousands of times, wasting minutes of your life, just write W slash. It'll help you take notes more complete. You'll be able to take more notes at one time because of it. So a sink is filled with water, and what we're going to say is it sits, it drains for a while. It drains. Someone will say someone pulls the plug. One pulls the plug. And it drains before stopping, or before the sink is empty, somebody puts the plug back in its place. Trevor, get your head up. The sink stays steady or stays filled. What's up, bud?
Could you say, someone wants to drink water out of the sink, cut it against it?
Sure, it's your story. The sink stays steady at this level for a period of time. Then somebody refills the sink. Okay, and that's how you write a sentence based off of a graph that you see. Hey guys, here's a wacky idea. Miss Erica Fox. Actually, Miss Erica Fox, you have been incredibly quiet, respectful, taking notes all day long today. So what I want you to do, hey, you see this? It's right, it's excited. See that? If you go slow, you can work it. Everybody else should give Erica her full attention, because you're going to be using this pretty soon too if you are well behaved. So I'm just going to get you set up with a pencil here, and I'm going to scroll you down on the screen, and just hang out right here, okay? I want you to just hang out here. You don't need to draw or write anything, but we're going to work together. Hey, Erica, I'm going to create you a graph, one of the best graphs you've ever seen in your entire life, just for you. That's what I'm going to do as a teacher.
I've seen some pretty good graphs.
No, but you've never seen one this good before. This is an incredible graph. So, Erica, what I want you to do, we're going to stick with the water level again, but I'm going to just change up the words, and we'll call this time. Hey, Erica, change the color. Choose any color up there that you want. Everybody else is sitting quietly for time out. I don't want to repeat that again. Y'all want to stick with this? Y'all need to give Erica her respect and time that she deserves. Okay, so what I want you to do here, Erica, is I'm going to say there is water, the water, or this, let's do this. I'm going to say a bucket is empty. A bucket is empty. A bucket is empty. Where would you put or start at empty? Yeah, and we're starting at the very beginning. But somebody over time steadily fills the bucket for a couple of minutes. Doesn't matter. She's just showing you that over time, and then it stays constant for a period of time. The bucket stays filled for a period of time, I could say. And from here, the person takes the bucket and pours it over some plants until the bucket is almost empty. And the bucket stays at that level for the rest of the day. So what Erica has just created is a graph. Great job, Erica. I'm going to have you pull that pencil away. There you go. And I'm going to take control here. And what Erica has said is, hey, bucket was empty. Bucket empty. There should be a C there. The bucket's empty, but somebody fills it. Fills bucket at a steady rate. Hey guys, here's another symbol. You probably see this one a lot, but it stands for at. I don't have to write the letter or the two words at when I can just do this. and it saves me time in the long run. So at a steady rate. The bucket stays, what was the next part right here, Erica? What were we saying right here, Cody? What did I say? From here to here, what's the bucket feeling?
What? That's when it's steady, right?
Yeah, the bucket stays filled for a period of time. I think you guys are reading too much into the story and not focusing on the actual concept of what a graph can help you do. What does a graph really help you do, guys, with words, with data? Yes?
Proves your point.
Time out. You guys are missing the big... I want to call on Allie here. Man, that is it right there, Allie. You're going to get a piece of candy for that. But it helps you visualize what you can't see before. It helps you visualize something you didn't see before. Because right now, or the reverse, maybe I see a graph, but I don't know what it's saying in words, and we're creating it in words right here. So the last part is somebody empties the bucket by filling bucket. They water their plants. Bucket is emptied by watering plants. What's up, dude?
It's also like a visual organization. Like
Yes.
Organized data, visual.
Dude, you're going to get some extra because it helps you to organize data as well. And I did spell that wrong, but that's okay. I know, Gavin. Thank you. Bucket empties.
Where's that?
We're okay. Empties. Oh. I'm going to make this a D. It's an E. Emptied over. Hey, guys. Stand up. Stand up. Everybody, stand up. Take a deep breath in. Let it out. Have a seat. Have a seat. Sit quiet. Lower your hands. I know you weren't doing anything for Jacob, but I'm going to talk to you and just be very stern and blunt. The way you guys are speaking out is inappropriate, and it's disrespectful. I don't appreciate it. Gavin, I've heard your voice more than once. Alex, I've heard your voice more than once. If this continues, boys, you are the first two that I'm going to pull the talk to. Those sitting around, I want to think twice about talking, hanging out near these guys if that's going to be the case. Because we're not going to have a good conversation with the class. You understand? You understand, correct? Thank you. Guys, I want to have fun with you. This stuff is fun. I know that's why y'all joke around, just to have fun. But you got to also remember, hey, you got to get through class. We only have a certain limited amount of time. You got to be respectful. Erica, thank you for helping out here. I'm going to take that. And I think we got time for one more problem. Lee, I'm going to give you the board here. Hold your thoughts there, buddy. So the bucket's emptied, and then what happens? It stays constant the rest of the day. And we're going to look at one more problem here. Hey, Lee. Check this out, dude. Hey, Lee, can you move that pen? Thanks, buddy. Okay. Here's what we're going to do. I want you to write a situation for this graph here, bud. And you get to make it up. You get to make it up, but here's what we know. This is the distance from the ground. So whatever you're doing is doing something. As time marches on, this is distance from the ground. Distance from the ground's increasing. And I'm going to let you use any color you want up here. Use your pen and choose any color. And then you're going to write a story with the pencil off to the right. It takes a little bit of time to learn it. You're doing good, bud. Now, as you're writing, Lee, take your time. You don't have to write in full sentences, But tell us what's happening in your words, and I want you to talk loud enough, and then you can write a couple words to explain, all right? So what's the example you want to use? What's happening? What's leaving the ground? So, okay, so you just say ball bounces, right? Well, you could write that part out. And then what happens after that? So guys, class, I want y'all to help him out. Not everyone yelling, but just talk with him and help him figure out what happens at the end of that. What's happening to the distance over time?
It's decreasing.
Yeah, the distance is decreasing.
And then it bounces up, and then the next time it bounces up, until the ball sits on the ground. Very, very good.
Guys, I'm going to write the homework on the board here. Who's got their hand raised? You can ask your question or state what you wanted to say. Today's homework this is in your red workbook. Your red worksheet workbook. You know which one I'm talking about? You're going to do, I know we're not on chapter 1, but you're going to do 1-8 in your workbook.
Well, big.
It's not in your homework. It's 1-8 in your workbook.
Oh, okay. Both pages, one side.
If it's 2 pages, 1-8 is 2 pages, then you do 2 pages. 1-8, I'm looking at it right now, guys, in your workbook, not your textbook, your workbook, 1-8. I'll tell you here in a second. It is only 1 page. So you only have 1 page of homework, and you're going to say, well, this is chapter 1. Well, guys, it's an intro to functions, and we are getting into functions with this chapter here. The homework tonight is intro to functions. It's page 8 in your workbook. Gavin and Alex would like to speak with you before you. Cody! You get about it. Don't forget, today is Monday's lunch. You are required to be here at lunch. You're welcome.
Right.
Thank you. Take care. Right. Check your what? If you're not my wife, you got that. Come in today. Take care. No. It's on your book, buddy. Good. Don't forget, the videos are on the website. They'll be on the website tonight if you need help.
Is it really with audio?
We will talk today on it. What's up, Lee? What's up, buddy? Cool. You just bring that to me when we get class. What'd you think of it, man? What's up? You'll get used to it. We'll use it more in class. But it's pretty cool stuff, isn't it? Hey, you got your hands full. I'll take care of it, okay? Hey, great job up there, man. Good stuff. All right, fellas. Hold your thought. That's where we're at. Here's the deal. I understand. Alice, I need you. I understand you guys are doing it. But when I'm asking you guys 5, 10, 15 times to quiet down, something's lacking. And it's probably the respect. I think you guys are respectful guys who need to get another chance. And in the future, I'm going to first call you guys. So it's not going to be a second. You guys, I asked you. So you guys, we talked about this. I'm calling home mom and dad. How do you think they're going to feel if I'm talking to them saying, hey, your kiddo's a great kid, but truthfully, they keep cutting up in class and they're disrupting and being disrespectful. Parents like it? Probably not. Your parents need it. So get to class and just think about that, right? Be respectful. Go get to class. We're going to have a good day tomorrow. I don't hate you guys. It's all right. Just give me all the facts. Have a good one. Come in, Ellie. Got that here? No. How we got that? Help us, man. Kid, we'll talk. Hey there, come on in. Come on in. What's your name? You feel like what's going on? Yes. You doing quick stuff. Here's the deal. Gotta know how to shake hands when you're thinking of something. Girl, what's up?
Wait, do you see an alternative? Does it fail now? Don't even get my notes out to you. Even though they're no dots to you. What? Even though they're no dots to you. That's wrong.
Whoa, bro.
Day 107. Day 117. I'm barely
Hey guys, have a seat in your desk. I got 2 kids and I am going to get them situated.
One 117.
No, that was the bell, which means it should be. All right, guys. So I'm going to take roll, and from there I'll get us into doing our test. We're going to go over the test that y'all took last week. Okay, guys, this is your work for right now. Oh, thank you. I need the answer key for you. Yes, sir.
I'll just change the homework schedule up there.
Huh?
I'll just change the homework schedule up there.
I will, yes, sir.
Okay, cool.
Guys, sit quietly, work on your homework. I wish you came in. I'll tell you later. All right, guys, looking good. I'm gonna move the worksheet down here some. All right, guys, I'm passing back the test. Here's the deal. If you did not get a 80 or higher, I would like you to come see me at 3 lunch today. If you did not get an 80% or higher, come and see me at lunch. Kaylee Elliott. Thank you, you're Kayla. You know that Kayla, you're Kayla Savage, silly girl.
the grade book this weekend, you could have already seen your grade. You'd already know what you got. Where's Ellie? Ellie? Ellie, she's here today? You are here. Yes.
What's that?
I don't round up on the test, but the grade book does it. Emily. Caroline. Grace. Where's Charlotte? Charlotte. Go get them. Alexis. Peter. Huh? How did I just realize? Who told me that? I wasn't looking at the last name when I was looking at the same time. I had to look at both at the same time. Duh. Your name was the one I see. I go, duh. So before that, I wasn't looking at the same time. I said, here. I got someone else. Caroline. No, he is. Noah.
Actually got a good grade.
Isaac. Jordan. David. Kendall. Hannah. Madison. Not here today. Jonathan. Hey guys, I need your attention now. Yes, ma'am. I have a second. I give you two. Can I have that? Pass it to me. Christian. Did anybody else not? Everybody raise your hand. Everybody raise your hand. Raise your hand. Lower your hands if you already got a test. Lower your hands if you don't have to. You don't have to raise it. So Sean, did you not get your test back? I'll get it back to you. Come and I need you, Sean. Sean, come here, buddy. I probably have it over here. Yeah? Great. All right, next slide. Oh, so this is fun. Hey, class! Raise your hands if you can hear me. Raise your hands if you can hear me. Raise your hand. Okay. Here's what I want to do. I want to go over the test. We're going to spend some time today on the test. Okay. Order rate. We're going to go over some problems that were commonly missed Now, here's the deal. A lot of problems were missed by real simple solution, like maybe you forgot to put a negative sign where it needed to go, or maybe you called an irrational value rational. Those were more of the common mistakes. However, the major points that were missed were due to lack of writing the problems down and solving them on scratch paper. Now, a good example here of somebody who may have done scratch work, but it was on the same sheet of paper, that's a good example of doing half effort. Because when you do scratch work on a test, I expect it to be on a clean sheet of paper. And I not only expect it to be on a clean sheet of paper, I expect the scratch work to be somewhat neat. And on top of that, I expect the scratch work to have the problem number next to it. That way I don't have to hunt and peck. I gave the benefit of the doubt this time. But those of you who did not use scratch paper, an alternate piece of blank paper or scratch paper, you're going to start missing more points in future tests. I just want to make sure that that is clear. I don't want to do it. I really want you to get as many points as you can. In fact, there were some people who made minor errors on every single problem. Not every problem, but a lot of problems, but they were minor errors. They saw all their work. It was real neat and easy to see where their mistakes were made. They missed half the point. Where somebody else who didn't show that work made the same mistake, they missed up to 5 points on that problem. So would you rather miss half a point or 5 points? It's your choice. But some people, because of that, maybe missed 5 problems. If you miss 5 problems, but you show all your work and miss half a point on each problem, how many points do you miss total? 2.5. So if out of 100, how much did you get? 97.5%. Here's the question. Those who did not show work, if they miss the same amount, a grand total, because they didn't show their work, they miss a grand total of 5 points per problem. Guess what? That's 25 total. That drops them to a 75% on the test. It's not worth it. I think some of you who got your test back today are realizing, man, I missed bucos points because I didn't show bucos a lot. I just missed a lot of points because I didn't show my work. That's your choice. I can't force you to do it. Can't force you to show your work. I can't force you to want to be as neat as possible. And yes, sir.
So if we miss on -5, what if we showed our work is only -?
It could be as low as half a point, depending on how much work you show. If you just write the problem down and leave it as so, I'll probably take off closer to 5 points still. But if you show me every single step, yeah. In fact, let's drop down to actually problems 40 and 42 real quick. Here's what we're going to do.